morning students. In the previous video, I explained congruent triangles. Once again, I want to recall that in the daily life situations where we are observing the congruent figures or congruent triangles, we have to give the example for congruent figures in our daily life situations. Suppose if you observe the fan, the blades of fans, 3 blades are there. 3 blades are congruent figures. Suppose you take your 10th class books, 10th class maths books only, particularly. 10th class maths books, they are congruent. In our school, you observe these tables or benches. Mostly they are congruent figures. And one more, in our house, if you observe the windows are congruent figures, same size and same shape. Like this, we have to give the examples for congruent figures in our daily life situations. Suppose scooty has 2 wheels. These 2 wheels are congruent figures. The bus has 4 wheels, 4-wheelers. Wheels are also congruent figures. Here we are using the congruent figures. Why we are learning the congruent figures? What is the necessity? Now, we will discuss about the similar figures. What is the difference of congruent figures and similar figures? Actual definition of congruent figures are having same shape and same size. Remember this. Same shape and same size. These 2 conditions. So that's why the symbol is also congruency symbol is here. This is the symbol for congruency. Here are 2 conditions. Same shape and same size. But what about the similar figures? Similar figures means 2 figures should have the same shape but not same size. Whether they are having same size or not. But it is not compulsory. Size is not compulsory. But shape is compulsory. They should have same shape. So these figures are called similar figures. Where we are observing similar figures in our daily life situations. Here you take the wheel of a bus to compare with the scooty tire. Both are circles, but size is different. They are similar figures. Same shape, but not same size. So, what is the definition of similar figures means? If 2 figures are having same shape, but not same size are called similar figures. For example, different TVs are there. 49 inches TV, 24 inches TV, 12 inches TV. These are all similarity. If you observe the TV showroom, number of TVs we can observe. These are all similar. Some are congruent. 49 inches TVs are all congruent figures. So, this is the definition of similarity of 2 figures. Now, particularly we discuss about the similar triangles. Similar triangles. What are the similar triangles? If you observe these 2 figures, this ABC is a triangle and DEF is a triangle. These 2 triangles are same shape but not same size. So if two triangles are having same shape but not same size are called similar triangles. Students, in the previous video, how to verify this congruency of triangles? I explained all these overlapping, that is the practical. In some cases it is not possible, then we are going to criteria. SSS, SAS, ASA, RHS, all these things we discussed about the congruent triangles. Suppose these two triangles are similar triangles. How to prove this? Some conditions are there. What are the conditions? Suppose, I will give you one more example, students. You take passport size photo, your photo or any, suppose any leader photo, passport size photo is there. We can enlarge that photos, card size photos are there, big size photos are there, cutouts also there. But if you observe this, in the passport size, what is the face or body language in the passport size, same will be in the cutout. How it is possible? How to enlarge this? How to enlarge this? Passport size we are enlarging to big one. How it is possible? That is the condition. That is the importance of similarity. In our phones also we are observing zooming the figure and reducing the figure. Zooming or enlarging the figure and reducing the figure. But when we are enlarging the figure, the ratio should be same. That is the important. Here also, passport size, when we are enlarging the passport size, the ratio is very important. Ratio is very important. We can increase the same ratio. I will explain this. Here, you observe this diagram. Here actually, this is one big triangle. One big triangle. And one more, if you observe, this is one more triangle. Here, one more triangle. Actually, this is the big one. We are reducing. If you observe, this big one triangle and the second triangle should be in the same ratio. What is the same ratio? What is the meaning of same ratio? Here also third triangle is there. And big triangle and the smaller one also having same ratio. So enlarging and reducing, or reducing or enlarging. When we are doing this process, the ratio is very important. Here you observe the circles. Here this is smaller one. We are enlarging the circles. It is the big one. What is the important of this enlarging here? Here the circle is having some radius. Suppose this is 5 centimeters, you think. Second circle is 6 or 7. 5, 7. And next one 9 or 8. Gradually we are increasing the radius, we can get the number of circles. Then these circles are having same ratio. What is the ratio here? Ratio of radii. 5:7:9:2 we are increasing. 5:7:9:11:13:15. This we have to maintain the ratio. So here actually what is the important rules of similar triangles? These are very important, my dear students. Listen carefully. What are the conditions of similar triangles? Number one, first one is corresponding angles are equal. That is the first condition. If you observe this figure, what are the corresponding angles here? These three, this angle and this one, this one. These three angles should be equal. Corresponding angles. Here also these three angles are equal. Suppose it is 70, it is also 70, it is also 70. It is 50, it is also 50, it is also 50. Here 70, 50. Suppose it is 60, 60, 60, 60. These are corresponding angles. That is the first condition. What is the first condition? Corresponding angles are equal. That is the first condition. I will write here. First condition is corresponding angles are equal. One more student here. Here this is the symbol for congruency. Here this is the symbol for congruency. What is the symbol for similarity? Here these are two conditions. Same shape and same size. But here similarity means we are taking only shape. So this is the symbol for similarity. Only this one. Suppose ABC and DEF are similar triangles. We can write triangle ABC similar to triangle DEF. This is the symbol for congruency. This is the symbol for similarity. Okay. Next, second one is very important, students. Here, second one is corresponding sides or corresponding sides are proportional. This is the second condition. Corresponding angles are equal. This is the first condition. Second condition, corresponding sides are proportional. But in the congruent triangles, corresponding angles are equal, corresponding sides are also equal. These are the conditions of congruent triangles. But similar triangles, corresponding angles are equal, but corresponding sides are proportional. What is the meaning of proportional? This is the ratio. How to verify the corresponding sides are proportional? I will give you an example. Suppose here AB is equal to 5 centimeters. Here this is 6 centimeters, 5 centimeters, 7 centimeters, 10 centimeters, 12 centimeters, 14 centimeters. Here observe, my dear students, ABC 5 centimeters, 6 centimeters and 7 centimeters. Here DEF 10, 12, 14. Now you observe the ratio of the sides. What is the ratio of the sides? AB and DE are corresponding sides. AB and DE are corresponding sides. What is the ratio? Here AB by DE is equal to 5 by 10. That is 1 by 2. AB by DE is equal to 1 by 2. Like that, AC by DF. What is the ratio? 7 by 14. That is also 1 by 2. 6 by 12. BC by EF is equal to 6 by 12. That is also 1 by 2. This is the proportionality. So now these sides are in proportional. Now only these two triangles are similar triangles. Here this is a very important condition. Corresponding angles are equal and corresponding sides are proportional. Otherwise, they are not similar triangles. Here also, these are the similar triangles. In this figure, these three are similar triangles. If you verify the sides, they should be proportional. Suppose this is 5 units, it should be 10. It is 6 units, it is 12. It is 7, it is 14. Or it is 10, it is 20. Here 15, it is 30. Here 20, it is 40. Like this, 1 by 2 or 1 by 3, any ratio should be equal. The condition is AB by DE is equal to BC by EF is equal to AC by DF. This is the proportionality of sides. So, if you reduce the figure or enlarging the figure, we have to maintain the ratio, that is proportional. We have to maintain the proportional, otherwise they are not similar figures. Remember this. So, these two conditions are important for similar triangles.